Long time ago, last year we actually did circles. So we graphed circles before we worked on the unit circle. And so this is an equation of a circle, but the problem is it's in the wrong form. So we need to get it in the correct form. The correct form, the standard form of a circle is x minus h squared plus a. Y minus k squared equals r squared. That's the standard form of a circle. Okay, that's our standard form of a circle. So I need to get this mess into this form. So we talked about the steps. Put the x's together first. So go x squared minus 10x. Leave a space. So I'm going to leave a little space here because I'm going to fill in the space. Okay, plus a y squared plus a 6y. Leave a little space because we're going to fill in the space. And then bring over the 18. So I'm going to bring over the 18 and subtract it, right? So I'm going to go minus 18, have a negative 18 over here. Okay? Now, what we want to do is put a number here. This number is made by taking half of this. We take half of this and square it. You guys remember that? So half of negative 10 is negative 5. Negative 5 squared is a positive 25. So I'm going to go plus 25 here. But I have to balance my equation because you add 25 to one side, you've got to add 25 to the other side to keep it balanced. So I'm going to add 25 over here. Okay, I'm going to take then the 6, take half the 6 is just 3. I'm going to square 3 and I get a positive 9. But again, I have to balance my equation, so I add 9 over here. Now the reason we do this process called completed square is it'll factor. So this will factor into an x minus 5, x minus 5, because we know 5 times 5 makes 25, and a negative 5 times plus a negative 5 makes negative 10. This will factor into a y plus 3, y plus 3, multiples 9 that add up to 6, and that equals, let's see, that's going to be a negative 9 and 25, what's that, 16? Is it 16?
Yeah.
Yeah, it's 16. I'm going to believe you. Okay, you got to be on top of this too. Okay, you got to help me. Okay, you got to be awake because you got to help me. Okay, so now if I have factored, this can be the same thing as an x minus 5 squared plus a y plus 3 squared equals a 16. Okay, great. It's in standard form. So the center of this circle is going to be the opposite. It's going to be a positive 5, negative 3. And the radius of this circle is going to be the square root of this number.
4.
Yeah, just 4. So now graphing it's going to be pretty easy. Try and make it as circular as you can. As long as it's in the right place and the right size, it's okay. It doesn't have to be beautiful. It doesn't have to be perfect, but I'm going to do my best to try and make it look nice. So I'm going to go to 5. 1, 2, 3, 4, 5. 1, 2, 3, negative 3 on my graph. And I'm going to then just go out 4, back 4, up 4, down 4. And I'll have 4 points, and then I'll just try and draw the best circle I can. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And with a little luck, it'll look more like a circle than an egg, but it's okay if yours end up looking like potatoes or eggs, because mine won't look perfect either, but there it is. There's my circles. Okay. The center is at 5, negative 3, and the radius is 4. Everybody good? Thumbs up? Can you do this tomorrow? Autumn? Yeah, this way? Yeah. Okay, no problem. Everybody can do this. This way? Okay, everybody have that? Okay, now, number 2, 3, and 4, okay, from the unit circle. So, and this will be gone tomorrow, so you're going to have your own circle. Hopefully you have your own circle. If you don't, then make sure you get one made before tomorrow, okay? So, tangent, 4 pi thirds. So I go to 4 pi thirds, which is here. Tangent, remember those are the values on the outside, the green ones, which is just the square root of 3. Okay? cosine 450. So 450 degrees is going around the circle at least once. So what I'm going to do is say, okay, well, 450 minus 360, because I'm going to go around the circle and then around a little bit more. Is it 90? Thanks. So it really is 90. So we're going to really go cosine of 90. So I go to 90. Yep. Awesome. 0. Cosine's the x value, right? So cosine's the x value, so it's got to be 0. Yeah, but you got the right idea. Thank you. So 0, okay? Now, cosecant is going to be the radius over the y value. The radius on the unit circle is 1. So 1 over the y value. Okay, so then I'm going to go to negative 3 pi 4. So it's a rotation. You're in your car, instead of going forward, you're going to go backwards, right? So 3 pi 4 is here. But let's rotate backwards, okay? So instead, negative 3 pi 4 is going to put us right there. Same amount of rotation, but instead of going forward in our car, we go backwards and rotate that far. Okay, same distance, but just backwards. Now, if we need the y value is negative square root of 2 over 2, right? So we're going to have an answer of a negative square root of 2 over 2. Now, that's not a very nice answer, but I do know that when I have 1 over a fraction, Caden's right, it flips it. So what happens, we end up getting a 2 over a negative square root of 2. So we just flip this, okay? We flip it, because 1 over any fraction is just the reciprocal. And then I'm going to fix this. So I'm going to multiply by square root of 2, square root of 2, and I'm going to get 2 square roots of 2 over a negative 2. I can cancel those and have just a negative square root of 2. Now, if you gave me this answer, I would not mark it wrong, okay? I don't really want that. I might take a half off for that answer. But if you give me this answer, I would take it, okay? I like this answer better. Okay? All right. All right, number 5, write an equation. Well, let's see. We've got several choices. I'm going to call it a cosine, and I'll show you why I'm going to call it a cosine. I'm going to start here and go to there. Do you see how one full period is from there to there? So again, and I'll leave this stuff up here, but that's a cosine, isn't it? You see it starts up, and it goes, looks exactly like a cosine, and then of course it repeats, okay? So I'd call that a cosine for sure. Let's go y equals cosine. Now the amplitude seems like it goes up a half and down a half, right? 1/2. Yeah. Autumn?
On number 4,
Mm-hmm.
on the bottom when we were multiplying out,
Right.
why didn't you multiply by
Oh, I could. It wouldn't make any difference. If you multiply by a negative, it would just bring the negative up here. You could. You could, yeah. I chose not to because I knew it was going to be negative either way, right?
Yeah.
Now, so you guys okay with 1/2 for the amplitude? Now, the big key is, what is b? B is always, the frequency is always 2 pi divided by the width. Well, how wide is one curve? Pi, right? So my b, and I'm going to write this up here, it's the same as this, it's just the opposite. So b, which is my frequency, is 2 pi divided by the width. And my width happens to be pi, so my frequency is 2, right? So I've got a cosine of 2x. There is no vertical and no horizontal shift. I mean, it starts right on the y-axis, and nothing's been moved vertically or horizontally. So that is my answer. Okay, and I'm gonna keep it fairly simple. This is not pre-calculus. This is algebra 2. So we're gonna do some simple graphs versus the harder ones, which we'll do in pre-calc. Okay. All right, number 6. Find all six trig ratios. Now, ratios are fractions. Ratios are fractions. So my answers have to be fractions. Okay. Now, I know this. In this example, the x value, it's a point, is -3. The y value is -4, but I don't know the radius, right? But I can find the radius by the Pythagoras theorem. I know I have an equation that is x squared plus y squared equals r squared. That's in my notes somewhere, right? And so I'd have a negative 3 squared plus a negative 4 squared equals r squared. So I get a 9 plus a 16 equals r squared. I get a 25 equals an r squared, or square root r is 5. Okay, cool. Sometimes it's not always a nice number, but I'm going to take these three values and I'm going to answer the question, okay? Now it gets easy. As long as you have this in your notes, it gets easy, okay? So sine of theta is equal to the y value over the r. Okay, that's in our notes somewhere. So in this case, it's just going to be negative 4 over 5. Cosine of theta is the x over the r. And again, that's in our notes somewhere, right? My x value is negative 3 over 5. Okay, these are my answers. This is what I want. Ratio means I want just the fraction. Tangent of my angle is my y over my x, which is my negative 4 over negative 3. And double negative, I'm just going to cancel the negatives. You guys are, I'm sure you're finding negative divided by negative, right? So that's my answer. Now, cosecant of theta is the r over the y, but we all know it's the opposite sign. You guys agree with that? Cosecant's the opposite sign, so that's easy. I'm just going to make it into a 5 over a negative 4. I know that secant of theta is the r over the x, but it's just the opposite of cosine, right? So that's easy. I'll just take that and make that a 5 over negative 3. And last but not least, almost done, and that's going to be the cotangent. Running out of room, but I'll squeeze cotangent in here. Cotangent of theta, which is the x over the y, but it's just the opposite tangent, which is easier. So I'll make it a 3 over 4, okay? Kind of squished it in, sorry about that. Okay, can you do that tomorrow?
Yeah.
Yeah. Yeah, just don't mess up on your Pythagorean theorem and you're going to be okay, all right? Yeah. What's that? Yeah, how do you get r? Just Pythagorean theorem. So you need this equation. X squared plus y squared equals y squared. You got to have that. I know the x is negative 3, the y is negative 4. Okay? And you know, Austin, don't mess this up. You guys know. What's a negative times a negative? Right? What's a negative times a negative? Don't mess this up. And don't rely on your calculator, because you're going to see something crazy. Want to see something crazy? Check this out. If I had in my calculator negative 3, whoops, clear that, negative 3 squared, right? What? Yeah, because I never squared the negative, did I? But I don't even need to do this because I'm smart enough to, I would never do this on a calculator. I know what negative 3 times negative 3 is. Why do I need a calculator to do that, right? So don't rely on the calculator because the calculator could mess you up, okay? All right? Okay, now, number 7. Let's graph this. Okay, my graph paper is over here. So I'll put a circle on it. Now, I know a couple of things. When I start this, the first thing I like to do is put down some things I know. I know the amplitude is 2, but it's got a negative, right? With a negative, a cosine curve normally looks like that. And that's my cosine curve, except for this one because the negative is going to be upside down. So what we're looking for is the negative cosine is going to look like this. It's going to start down. So I'm just setting myself up. I know it's going to look like this. This is the shape I want. I know it's going to go from a 2 to a negative 2, because that's my amplitude. But what I want to know now is how wide is the curve, okay? So what's my curve width, or my period? My period is my curve width. And my curve width is 2 pi divided by my frequency, okay? Now, thirds, 2 pi thirds, okay? So I'm going to go to my axes, and I'm not going to go, this one I'm not going to go pi fourths. I got to go pi thirds because of the 2/3. So now I'm going to take my graph, try to put that in here. Let's put down what I know. Okay, and put my x, my y-axis down. I'm going to go from a 2 to a -2, right? And I need this shape, but instead of, I'm going to go pi thirds, 2 pi thirds, 3 pi thirds, which is pi. I need to make my graph a little bit longer. I'll put graph paper on it. On the test tomorrow, you'll have the graph on it, okay? All right. 4 pi thirds, 5 pi thirds, and 6 pi thirds. Okay, so now, let's put this shape, between here and here. Let's put this shape right here, between here and here, between here and here. Now, these are invisible lines, but I'm just putting them in there because it's going to help me, okay? And if I put one here, one here, one here, that gives me 3 of them, which is what I expect, frequency of 3. So let's see if I can do that. So I'm taking this shape right here, right? So I know if I take this shape, it starts down at -2, and it's going to end down at -2. So I put the beginning 2 dots. The middle of the curve is up at 2. It's going to go through here at pi 6. It's going to go through here. 5 pi 6. Okay, so here's one curve. Here's one. And I'm just going to repeat that pattern 2 more times so I get a frequency of 3. Okay, let's do it again. Here, 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 here. Okay, I'm going to go here, 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 and here. Okay, and it goes on forever and ever. But I have 1, 2, 3 curves. I've got an upside down cosine curve, right? From 2 to -2. Thumbs up? Okay. This way, Autumn? Yeah, I will. And then, let's see, how's that if I put it all there? You got everything? And you got, that way you can see the graph also. I think everything's there you need, right? For this problem. Give me thumbs up when you get it, okay? And then we'll flip the page and we'll look at the next problem, okay? Okay, flip the page. Okay, number 8 and number 9. So you need a couple of formulas, and the formulas are this. First of all, to convert to degrees, we're going to go the radian. We're going to go degree is equal to. Okay, we're going to convert this to degrees. It's going to be my 180 over pi times my radian. That's my formula I need for this, okay? So, all right, I'm going to go 180 over pi times 5 pi eighths. I'll cancel the pi's, and I'm going to use my calculator. Well, I'll use 180 times 5 divided by 8, and I get an answer of about 112, thank you, 112.5 degrees. Okay. 9, convert to radians. Here's my formula. Radians are equal to, I'm going to go theta over 180 pi. Okay, and if I can have it in terms of pi, it'd be really helpful. Okay, Jay, did you get the homework?
I'll grab it from right now.
Okay, and I'm gonna put this up on the canvas. Okay.
Thanks.
Okay, so then I'm going to go, my radian is equal to -200 over 180 pi. And I'm just going to reduce this fraction. I'm going to reduce this. Now, you do not have to be a mathematical genius to reduce. You have to know where. The calculator will do it for you, even though I could probably do this. 20 over 180 or 10 ninths. You guys see 10 ninths? If you can't see 10 ninths, If 10/9 is not in your brain, then just go, okay, well, negative 200 divided by 180, and go to the math button. It's already highlighted on fraction. I went to the math button. It's already highlighted there. And it reduces it to, hey, what do you know, negative 10/9. So in terms of a reduced fraction, it's negative 10/9 pi. How am I doing? Okay, number 10. Almost there. Okay, a 6-foot man sights the top of a building 100 feet away. I had this all messed up because I had meters there and feet there, so I had to fix it. Silly me. So, how tall is the building? Well, we can do this. We've done this. It's just regular right triangle. Here's my man. Here's my dude. He's 6 feet, and he's looking up at a building. Now, of course, things are not drawn to perspective, right? At all. This triangle I'm looking for is suspended 6 feet up, right? 90 degrees. I have 54 degrees here, okay? And we'll call that x. Now, when I find the height of x, I'll add the 6 in. My triangle's suspended because he's taking it from his eye, right? So then, I'm going to set up opposite, and this is obviously with my 100. Opposite adjacent. Opposite adjacent is going to be tangent, right? Tangent of 54 equals my opposite over my adjacent, right? I'll multiply up 100. 100 tan of 54 equals x. Now, before you push your button, what do you have to be careful of? The mode. Yes, and I know it's going to be, you ready? Degree mode, right? Degree, because you see the little degree symbol? Thanks, Parker. So make sure you're in degree mode and go 100 tangent 54. Can you do that for me? Yep. What'd you get? 136 points. 137.63. And then we'll add in our 6, right? What's that? 142? 142.63 feet. Okay, can you do that? I mean, that's just old stuff. A little bit of right triangle trig in there. Hey, we're almost done. Okay, number 11, the tide problem. All right, I was not here to do it with you, but I'll do it with you again, okay? So when I do the tide problem, the first thing I like to do is just get a picture of what it looks like. So I do the tide problem. Go ahead and sketch in my x, y axis. I'm going to go time. So I need to do 24 hours. So let's go midnight. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's noon. And then I'm going to go, instead of 1, I'm going to go 13, 14, 15, 16, 17, 18. 18 is really 6 o'clock p.m. 19, 20, 21, 22, 23, 24. There's my 24, or back to midnight. All right, 2.8, negative 2.8, so I'm going to go at least 3 and negative 3. And I'm just going to do dot to dot. So if high tide was 2.8, so I'll go 2.8 there for midnight. And low tide was 7:45. So I'm going to estimate where 7:45 is, and I'll go negative 2.8. Okay, I'll just stop right there for a second, okay? High tide, 2.8. Low tide, so this is about 7 here. So how long is a tide? Well, a half tide, the half tide is 7:45 from high to low, right? If I need a full tide, I'm just going to add them. So if I want a full tide, I add another 7:45. Now this is a little hard to add time. Do you mind if we change things to decimals? It's going to be better to change to decimals anyway. So 45 minutes is 3/4 of an hour. Everybody good with that? 45 minutes, 3/4 of an hour. So let's change this to 7.75. We'll add another 7.75. We're going to need the decimal anyway. which is going to be a 15.5. Yeah, those.
So 3:30.
Yeah, there you go. There you go. Caden's way ahead of us. I like that. Okay, so that means the next high tide is at 3:30. Because if I go 12, 13, 14, 15 and a half, okay, that's 1 o'clock, 2, 3, 3:30. Or you could go military time. The next high tide is right there. Okay, I can sketch it in my tide problem. Okay, there we go. Okay, now I got the sketch, now the equation. Am I going too fast? I sure can, okay? I don't mind at all, okay? I've got C already done, don't I? Yeah. It helps to get the next high tide because then you can see one full curve. Okay, so what I did to make it easy for me, I needed to make the time into a decimal. I really did. I needed to make the time into a decimal, okay? So 45 minutes, 3/4 of an hour, 0.75. That should be easy to comprehend. I added 7.75 high tide to low tide to another 7.75 low tide to high tide, so that a full tide, high tide to high tide is 15.5 hours. That's my period. That's my period. That's my curve width in terms of time. So my equation, y equals, now what's my amplitude? 2.8. Cosine. Everybody agree with cosine because we're starting up? Now B, to find B, we're going to go 2 pi divided by the curve width. What's my curve width? High tide to high tide? 15.5 is the curve width. It's in terms of time, isn't it? How wide is the curve? It's in terms of hours. So it's 15.5. So that's going to go here. 2 pi divided by 15.5. Now, if you want to make that into a decimal, you can. Okay. Now, times t, and that is my equation. All right. I've already got part C. When is the next high tide? The next high tide happens to be at, we already did it, it's either military time, 15:30 military time, or I like what Caden said, 3:30 p.m. I like that answer better because it makes more sense to us, right? Okay, now the extra might be this. What's the height of the tide at noon? If I asked you that, how would you do it? Plug 12 in for t, right? Now if you use your calculator, what's your mode have to be? Radians, okay? All right, how's that? Okay, now we have 15 minutes. I got a little bit of work for you to do.